Okay, so I've done a bit of exercise 11.2 for you in advance. It's asking in question 7 for the equation of the locus of a point P. So here's my point P, just any generic P, which is x and y. Now, it's going to move so that PA equals twice PB. Alright, so PA is double PB. We need that. They've given me A and they've given me B. So I'm going to use my distance formula, but you'll notice that the distance formula has square roots everywhere. So I'd rather use PA squared and do away with the square root. Okay, because PA squared, if you have a look over here, is going to be the same thing. I haven't bothered simplifying that. I just want to show you that it's the same thing without the square root. So I'll be looking at PA squared. So PA squared, I apply the formula with A and P, and I get this line here. That simplifies to this line here. Then PB squared, I'm using P and B this time, using the distance formula but without the square root. So that's what PB squared is, which simplifies to this line. Now the definition, the Locus definition was that PA was twice PB. But I've only got expressions for PA squared and PB squared, so I better square both sides. So after squaring both sides, this is now my new Locus definition that I'll be using, which is valid because it follows from the previous definition. So now I find my PA squared, put it on the left-hand side, and I find my PB squared and put it on the right-hand side with a 4 in front of it, just like the definition asks. Then it's a matter of expanding them out and then putting it into general form. That means getting everything over to one side and equals to 0. So how do I know which side I want 0 on? Well, I just had a look and saw that, well, I'd like to try and end up with positives. So I decided I would take x squared off this side, which means I take it off that side. That leaves me with the 3x squared, which is nice and positive. If I took a 4x squared off, I'd end up with a negative on that side, which is fine. It would just mean at the end I have to change all my signs, but I try and avoid that. So there's my answer there. So the next one, number 8, same deal, but this time the Locus definition tells me that the ratio of PA to PB is 3 to 2. So I have to use that for my definition. I go ahead and find PA, I go ahead and find PB. Well, actually squared, PA squared, PB squared. That way we don't have to deal with square root signs. And if PA over PB is 3 on 2, well, what does that tell me about PA squared on PB squared? Well, that's got to be 3 squared on 2 squared, which is 9 on 4. So that's the definition I'll be using from now on, which is quite legitimate because it follows from the definition they gave me. So now it's just a matter of putting PA squared over PB squared and setting that equal to a 9 on 4, expanding out the brackets, doing a cross multiply, then putting it in general form, which gets it all over to one side equal to 0, and then there's my answer. Pause when you need to. Number 10. Now this one's slightly different because they're giving me a point and a line. Now see this line here, y equals minus 5. That's this one here. So it's always good to draw these ones if you're not sure what's going on. So where's A? A is 0, 5. So there's A. That's that one there. And P, well, where did I decide to put P? Well, it told me in the Locus definition that the distance between PA and P, well, from P to A and the distance from P to B was the same. So how do you have a distance from a point to a line? It has to be perpendicular. So it's no good just having any old point to that line, like any old, joining there. That's silly. So it's always the shortest one. It's assumed that the distance between a point and a line is the shortest one. So that PB has to be exactly the same as that PA. See? That is the same as that. So then I go ahead and use that PA equals PB, but then I'll square them both because I've got it in terms of squareds. Substitute in for PA squared, PB squared. Expand out the brackets. Tidy up by bringing everything over to one side, and there's my equation. I'm going to talk about what all these are later on, but at the moment we're just doing the exercise of finding the equation of the locus. So in question 11, same deal. So I've got this, in question 11 they told me that I had x equals 6. I didn't bother writing that down, that was a bit naughty. X equals 6. So the distance, well, let's draw x equals 6. There's x equals 6. Not the best drawing you'll ever see. That's that. Now the distance between the point P and that line is always the shortest distance, so it's that one. Maybe I'll do it in a different colour. So that PB there has to be 90 degrees, all right? And it's going to be the same as that PA there. So, well, that means that I can get the coordinates of B. B is going to be 6y. Can you see why it's 6y? Because it's 6 along here on the x-axis, and y, I don't know, so I'll just call it y on the y-axis. So it's got coordinates 6y. Okay, so let's just put those into my formulas for distance, set them equal. Remembering though that I'm using the PA squared equals PB squared form, which is quite legitimate because we know that PA equals PB, so PA squared is also going to be PB squared. Expand out the brackets, tidy up, and away you go. What else have I done? Here's another one, 12, same deal, y equals 3, that's this line here. How do I get the coordinates of the point P, the shortest distance? See, that shortest distance has to be 90 degrees. How do I get the coordinates there? Well, if I have a look, I don't know what the x coordinate is, I'll just call it x. And I do know what the y coordinate is, it's 3. So that's my coordinates for B. A I've got 1 minus 1, so away we go. Now these are the same, so I'll indicate that with a double notch there. So that, I'll just get rid of that, it's a bit messy. So that length there is the same as that length there. That's what it's telling me here in the locus definition. Doesn't look like it in my diagram, but the 2 notches tell you what it is. It makes up for the dodgy diagram. So now let's put in for PA squared and PB squared. Expand out your brackets, get everything over to one side and get your answer. 13, same deal. Y equals 3. It said in the question, so that it said the distance between some point and that line, y equals 3, had to be the same as to A, which is at 0 minus 3. So I probably should have a minus 3 sitting there. And I need to indicate that these are the same length by doing little double notches. And it's the same process. Hope that helps.